reduces pathogen replication so in Drosophila, it reduces virus replication of a wide variety of viruses. And so in Australia, we have a growing problem of dengue virus, and so as part of the Eliminate Dengue worldwide scheme, if you add Wolbachia to the Aedes aegypti mosquito, it doesn't transmit dengue virus. And recently, there's a lot of work looking into how Wolbachia can affect replication of Zika virus, which is growing a threat, but we really don't understand how it works. And so on the other side, Wolbachia is found in nematodes, which are responsible for elephantitis, other situations where nematodes, worms are blocking the lymph nodes. And when you remove Wolbachia from these systems, you're able to treat the parasitic infections. So in arthropods, it's good if you add it, and in nematodes, it's good if you get rid of it. So what I wanted to ask was whether there's similar properties across infections of Wolbachia and these different hosts. So when you take Wolbachia out, do you see similar gene up and down regulations? And then, do certain kinds of hosts have specific responses to Wolbachia? So you'd expect things so diverse as nematodes and arthropods that there's going to be nothing in common. But that's not actually what I found. So when you take Wolbachia out of these systems, you see an upregulated variety of genes in energy production, which we hypothesize that this is because the system is recovering from Wolbachia, originally sort of predating on the host. There's also a change in the neurophysiology of the host, and that's very interesting because we know that Wolbachia is active in some way in mosquitoes in altering the brain morphology of the host, and that can have something to do with the way that Wolbachia-infected mosquitoes also behave differently when you infect them with various viruses. Also, you find downregulation of things, so protein degradation, autophagy, which is important for dengue virus blocking, and also notch signaling, which has a lot to do with development. So everyone knows about, there's a lot of information about how Wolbachia affects the reproductive abilities of their host, and so there could be something happening about that around when there's Wolbachia is absent. I've also found some differences, but it's more striking that we found these similarities because they're so different. So the next questions that I'm trying to ask are that there must be some differences, and I'm aiming to produce a list of target genes. So all of my work is bioinformatics, but there are other people in my lab who are interested in looking at this phenomenon of Wolbachia versus dengue virus in mosquitoes, and ideally I'll be able to give them a list of target genes in order to go and find out more about when you take them out and block them, use RNAi in mosquitoes, does something interesting happen in the way that they respond to dengue virus. That's everything because I naively left time for questions. Does anyone want to ask a question? Yes.
Not all Wolbachia strains are the same, at least in dengue blocking. If you started comparing them in the same host for differences in genes?
I don't have enough transcriptomic data to do that. So what I've been doing instead is looking at novel ones